Dear students, in the last session we had learned about Ohm's law, and I hope you remember it because today we are going to need this law to carry on with our next topics, which are resistors in series and resistors in parallel. Students, today we will be continuing with the lesson electricity, which is chapter number 12, and we will be studying about resistance of system of resistors and series combination. This is part number 4 of the lesson. In the last session we had studied about Ohm's law, factors on which the resistance of the conductor depends, and we had also dealt with electrical resistivity. Students, before starting with today's topic, I would like to revise Ohm's law because this is a topic in which there are few relations which we will be needing in our future topics. So let us start revising the Ohm's law first, and then we will be continuing with next topic. So let us just quickly revise Ohm's law. What is Ohm's law? The potential difference V across the ends of the given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. This is Ohm's law. In short, potential difference is directly proportional to electric current. This is Ohm's law. So to put it in mathematical form, V is proportional to I, and if V is proportional to I, then as per mathematical rule of variations, V upon I will be constant, and this constant is taken as R. R means resistance. So V upon I is equal to R is the relation for Ohm's law. Students, this can also be written as V is equal to IR. This is also a relation which we many times use in numerical problems. Students, keep in mind this relation because we will be using it in one of our topic. So the next topic is resistance of system of resistors. In various electrical gadgets, we often use resistors in various combinations. So there can be two methods of combining the resistors. One is called series combination and another is called parallel combination. This is series combination and this is parallel combination. What is difference between the two? Here the resistors are connected end to end, while here they have a common point. Okay. So series combination, when resistors are connected end to end, then it becomes series combination. When resistors are connected in series, current remains same. Remember, when resistors are connected in series, current remains same. So current doesn't change in case of series combination. And what is series combination? When resistors are connected end to end, that is called as series combination. However, we must note that the potential difference is different for different resistors. Okay, so the total potential difference across the combination of resistor in series is equal to sum of the potential difference across individual resistor. For example, in earlier case, there was, I will show you a diagram. In earlier case, this was a diagram, right? And there are three resistors, R1, R2 and R3. In each of these resistors, current will remain same. So the current that is flowing through all these three resistors will not change. But if you check the potential difference across each resistor, you will find that if the resistors are different, then potential difference will also be different. And the total potential difference will be sum of all the potential differences. Students, now we will be deriving a relation for a combined resistance in case of series combination. And we start with potential difference. So total potential difference in case of series resistance is V is equal to V1 plus V2 plus V3. So when we add all the potential differences, we get a total potential difference. Now, as per Ohm's law, just now we had studied V is equal to IR. That's why I revised, because I knew that we are going to use this relation. So what is V? V is equal to IR, and this is as per Ohm's law. Now, For different resistors, there will be different potential difference. So V1, V2 and V3 will be what? V1 is equal to IR1, then V2 is equal to IR2 and V3 will be IR3. Now here if you observe carefully, I has remained same throughout. Why? Because as I said earlier, current does not change. Whatever may be the case, but only in case of series combination. In case of series combination, current does not change. So I have kept I same everywhere. Now, what will be if I consider this equation and if I replace V1, V2, V3 and V in this particular relation, which is V is equal to V1 plus V2 plus V3, I will get IR is equal to IR1 plus IR2 plus IR3. Now, if you see, I is common on both the sides, left hand side as well as right hand side. So I can cancel I from all the sides so that I will get R is equal to R1 plus R2 plus R3. Students, this is the final relation for series combination. So in case of series combination, if there are n number of resistors, you will add all the resistance to get a combined resistance. So in case of series combination, if there are n resistors, then R will be equal to R1 plus R2 plus R3 dot so on until Rn. So that is a general relation for series combination. However, in problems many times we don't give number of resistors, lot of resistors. You will get hardly 3 or 4 resistors, but the process is same. You have to add all the resistors, and I think it is simple to add because you already know addition. Well, that was all for today. Now there are few things that you can try out at home, and that is assignment of 4 questions. First question is, what are the two ways of combining the resistors? Second question is, what is series combination of resistors? Third is, what is parallel combination of resistors? And fourth is, derive relation for series combination of resistors. I will repeat the question. First question is, what are the two ways of combining resistors? Then next is, what is series combination of resistors? Third is, what is parallel combination of resistors? And the last question is, derive relation for series combination of resistors. So that was all for today, students. I hope you understood what I tried to teach you. But if you have any doubts, you can ask me anytime. You can put your questions in comment box. In the next session, we will be learning about this parallel combination, which is another method of combining resistors. So bye for now. See you. Take care.